So this lesson today is deriving arc length formula using similar circles and finding arc length. We are going to use similarity of circles to derive the arc length formula and to solve for arc length. And we are going over standard 5b or IOA 5b. Using similarity to derive the fact that length of arc, i.e. arc length, intercepted by the angle is proportional to the radius. Derive the formula for the area of a sector. We're going to do that tomorrow, and then we're going to solve mathematically applications problems, solving them, using them. Okay, so first I want to ask you guys, what do you notice and what do you wonder? Okay, so what do you notice? Trying to move that, not moving. What do you notice about this? We have a radius, right? And it says the circumference is 2 pi r. So what I want to tell y'all is if I take this radius right here and I start putting it around this circle, it actually comes out to be 6.28 radii that create the circumference of the circle. And that happens every time. So to answer this question, how is pi discovered? They took the radius and they started putting it around this circle, okay? And when they put it around this circle, they found that it went around the circle 6.28 times. Got it? And that is a consistent value. Every time you find a radius, it will go around the circle 6.28 times. And remember, pi is 3.14, right? That's how they found pi. Okay, so half the circle is actually pi. The whole circle is 2 pi, okay? And we're going to talk about this even later, more. So it says, consider the larger gear represented by the circle O containing a central angle AOB. So it's talking about this gear right here, and that's angle AOB right there, which it says is 60 degrees. And then a minor arc AB, so minor arc AB right here, okay? And a major arc ACB, as shown. It says, consider the smaller gear represented by circle E. This is our circle E right here, okay? It says, containing a central angle FEG. FEG is that angle, whose measure is also 60 degrees. And then a minor arc FG and a major arc FDG. It says, compare the two gears. Okay, so it says, is the length of the radii in the larger gear proportional to the length of the radii in the small gear? Explain your reasoning. Well, what we could do is we could literally take this radii right here. Whoops. Be my color. That radii. So AO. And we could put it over the radii of FE. That's what it means by proportional. Isn't that a proportional? It's just a fraction, right? So yes, we could put one over top of the other. And it says determine the degree measure of the minor arc in each circle. Well, the degree measure is 60 there and 60 here. That's what it is in both, right? 60 degrees. Okay, then it says what is the ratio of the degree measure of the minor arc to the degree measure of the entire circle? So to do that ratio, we're going to put 60 over 360. Again, what does it say? The degree measure of the minor arc, that was the 60, to the degree measure of the entire circle for both gears. Because remember, the entire circle for both gears is 360 degrees. So number 2 says, if the length of the radius of the large gear, or OB, is equal to 4 centimeters, determine the circumference of circle O. Remember, circumference is 2 pi r. Okay, so that means we're going to do 2 times our radius. And I'm always going to do this way, 2 times 4, okay, and then pi. So that's just going to be 8 pi, right? And that's going to be centimeters. Now, if it asked us to compute this approximately, we would multiply 8 times pi. And when we multiply 8 times pi with our calculators, that's an approximate answer, remember, because we're going to round. So that's going to be 25.13 centimeters, okay? Now, the next one says use the circumference of circle O determined in number 2 and the ratio determined in number 1C to solve the length of the minor arc. Okay, so now we're going to do our 8 pi, and I'm just going to use the 8 pi, times the 360, or sorry, times the 60 over 360. Okay, so now when I do that in my calculator, I actually get 4.19 centimeters. Okay, And the 60 over 360 is that ratio, right? Okay, then it says if the length of the radius of small gear EF is equal to 2 centimeters, now we're doing 2 times 2, right? 2 times 2 times our pi. So that's going to be equal to 4 pi, and again, centimeters. Now we're going to multiply that times our pi, and that's going to give us our approximate answer. So this is going to be 12.57 centimeters, right? Okay. So then it says use the circumference of circle E determined in number 4 and the ratio determined in 1C to solve for the length of the minor arc for circle E. Okay, so for this one, again, we're going to do our 4 pi times our 60, and we're going to divide that by 360. We're going to actually divide it all by 360. Okay, so we can do that in our calculator. 4 times pi times 60 over 360, and that gives us 2.09 centimeters. All right, so this next part says deriving the arc length using similar circles. So arc length is a linear measurement that represents a portion of the circumference of the circle. So we're talking about a portion of the circumference, right? A part or a fraction, okay? And that's where our central measure over our 360 comes from. It says to determine the arc length, you multiply the circumference of the circle by a fraction representing a portion of the circumference determined by the central angle measure M. So arc length is equal to the central measure divided by 360 times the circumference, okay? So arc length is equal to the measure of over 360 times 2 pi r, because that is the equation for our circumference. Now there's a proportional relationship between the measure of an arc length and the circumference of the circle. So the arc length over the circumference is also equal to the central angle measure over 360 degrees, right? So the arc length is part of the circumference. The central angle measure is part of the whole circle. All right, so let's practice. The length of an arc is a fraction of the circumference of the circle. So arc length is the distance along an arc measured in linear units. So that is the length of this right here, AB arc. So that's going to be 2 pi r, that's circumference, times the measure of the central angle, that's this right here, or the arc, either one, okay? That could be in degrees, this could be in degrees. Remember, central angles are equal to arcs. And then that's over 360. So this is the way we recommend computing arc length. Always write 2 answers, one with pi and one when you multiply it by pi. So this is the recommendation. Do the 2 times the radius times whatever theta is, and that could be the central angle or the degrees of the arc, over 360. You do that first, and then you multiply by pi. Okay, so you're going to leave pi in your answer initially, and then you're going to multiply by pi. So now we're going to use this. Find the arc length, each arc length, give your answer in terms of pi and round it to the nearest hundredth. So we're going to do it both ways. So remember again, what we're going to do is we're going to do 2 times the radius times theta over 360 times our pi. We're going to do our pi last, okay? So our radius here is 8 and our theta is the 134. So this is how we're going to set this up. 2 times the 8 times our 134, going to divide all that by 360. And we're not going to multiply by pi first because we want pi in our answer, okay? So this is going to be an equal to answer because it's exact. Not really, but kind of. 5.96 pi centimeters, because we did still round that 5.96, right? Okay. Now I want you to multiply that 5, whatever you have in your calculator, by pi. Okay, so now this answer is going to be 18.71. And this is what I was talking about not rounding till the end. Okay, so we don't round things and then round them again. Okay, so you don't round till the end. All right, our next one, it says find arc length with the arc measure of 62 degrees. So this is our theta, right? And a radius of 2 meters. So now we know what r is, right? So this is going to be 2 times 2 times our theta, which is 62, divide all that by 360, and leave pi in the answer for right now, right? Okay, so our answer right now is going to be 0.69 pi, and again, this is meters. Then we're going to multiply by that pi, okay? So this is our that's our equal to answer. This is our approximate answer, okay? So this is going to be 2.16 meters when we multiply 0.69 times the pi in your calculator, okay? we got another one. So this one is your you do. So you can pause the video here and do this one and come back to me when you're done. Okay, so again, this is our theta, this is our r, right? You're going to go 2 times 5 times 186 divided by 360. We're leaving that pi on the answer, right? So when we do that, I got 5.17 pi, and this would be inches, right? And then when I multiplied it, that's going to be my approximate answer again, and this is going to be 16.23 inches. Okay, go ahead and do the next two and come back to me when you're done. So this is our radius, right? This is our theta. So we're going to do 2 times our 6 times our 40 divided by 360, and then leave our pi for the end again, remember. So this is going to be 1.33 pi meters. That's our, and then our approximate answer when we multiply by pi is going to be 4.19 meters. Okay, last one, y'all. Theta is the 135. Our radius is obviously our radius. So 2 times 4 times 135 divided by 360. Leave your pi for last. Okay? So when we do that, I got my equal to was 3 pi centimeters. And then when I multiply 3 times pi, my approximate answer was 9.42 centimeters. Okay? All right, now this one says given the arc length. Okay, so that means now we've got L. So L is equal to, again, remember, 2 times R times theta over 360 times pi, right? Now pi's on the top, okay? So we're going to do this one a little bit different. We're going to use the formula straight up. So this is now L, right? So that's going to be 18.85, and that's going to be equal to, it says the radius, so we've got 2 times our radius, which is 9, and it's asking us for theta. Isn't this asking us for theta, y'all? So that was our R, right? Okay, then we got our theta, right? And then we got our pi. I'm going to leave it on top this time. And then over 360, okay? So how do we get rid of the 360? Wow, this thing is moving. We multiply both sides by 360, right? Multiply both sides by 360. When I multiply 360 times the 18.85, I got 6,786, and that equals our 18. I'm going to go ahead and simplify that right there. Theta pi, okay? So what I'm going to do is I'm just going to go ahead and step this out, guys, okay? So I'm going to now divide by, you could divide by 18 pi. I'm just going to divide by 18, okay? Some of y'all, it's going to be easier this way, okay? So I'm going to divide by 18. When I do that, I get 377 equals theta times pi. And then what do you think we're going to divide by now? You got it, pi, right? Because we're trying to get theta. So we're going to divide both sides by pi. And when we do that, oh my goodness, why is this thing moving like this? Theta is equal to 120 degrees. And it told us to round to the nearest degree for the answer, okay? All right, we're going to do another one together, and then you guys are going to do one, okay? So here again, our length is that. So we're going to do 22.34 is equal to 2 times our 10 times our theta times our pi over 360. So once again, how do we get rid of the 360? We multiply, right? So we're going to multiply both sides by our 360. So when we do that, I got 8,024.4. And I'm going to simplify this. So that's going to be 20 times theta times pi. So once again, everybody listen, you could divide by 20 pi. Okay, and you can do this in your calculator. So you can take that 8024, which should be in your calculator right now, and you could divide this by 20 pi. Divide this by 20 pi, okay? And so then that would give you that theta was equal to 128 degrees, okay? Now you go ahead and do this one. Come back to me when you're done. All right, so this is length again. So this is 39.27 is equal to 2 times the radius times theta times pi over 360. I'm going to step it out like we did before. Multiply both sides by 360. And again, you can do it whichever way you want as far as our next step is concerned. Oh, radius, sorry. I didn't put the radius in there, did I? 2 times 18. My bad. 2 times 18, right? Okay, so when I did that, I got 14137.2 is equal to 36 theta pi. So here again, can't we divide both sides by 36 theta? 36 pi. Divide by 36 pi. Divide this by 36 pi. So theta is equal to 125 degrees here. Okay? All right, so our next one says given the arc length, we're given the arc length again, is 30.54, and the arc is 25 degrees. What is the radius? Now, this could be a central angle or an arc, remember. So, again, length is equal to 2 times the radius times theta times pi over 360, right? Okay, so what we're going to do is substitute in what we got. So this is our length, right? This is now theta, and we're looking for the radius, okay? So we've got 30.54 is equal to 2 times our radius times our 250 times our pi divided by our 360. So we're going to get rid of that 360 the same way we have been. We're going to multiply both sides by 360, okay? So when we do that, I got 10994.4 equals, and remember that's canceling that out, right? So now 2 times 250 is 500 r pi. Okay, so once again, we can now divide this by 500 pi and this by 500 pi, right? When you divide both of those by 500 pi, I got that the radius is equal to, it was 6.99 and then another 9, so it actually rounds up to 7 meters because the third digit was rounding the next one and the next one, okay? All right, so again, this is our L. This is our theta. We're looking for R, okay? So we got 1.57 is equal to 2 times our radius. We're looking for our radius. Remember, our theta is 30. And pi, again, divided by 360. How do we get rid of the 360? You got it. Multiply both sides by it. So when I did that, that gave me 565.2, and that's equal to 2 times 30 is 60 r pi, right? So we're going to divide both sides by 60 pi. And when you're doing this in the calculator, make sure that you put this in parentheses, okay? Because if you don't, it's going to divide by 60 and then multiply by pi. Okay, so if you have to do it in 2 steps, then make sure you do it in 2 steps to get the answer right. So the radius here, again, it rounded up to 3 yards, right? All right, do this last one on your own and come back to me when you're done. Okay, this is L, this is theta. So 14.66 is equal to 2 times the radius times theta times pi divided by 360. Multiply both sides by, you got it, 360, right? It's going to be a big number, isn't it, y'all? I got 5277.6. That's going to be equal to, oh, what was our, oh, I forgot to put that right there, y'all. That should have been a 70, right? 2 times 70 is 140 r pi. So once again, divide both sides by 140 pi. Divide this by 140 pi. Notice I put it in parentheses this time just to make sure I get the right answer. And again, the radius is equal to 12 miles.